Hi there, wishing our panel a very good day. My name is Yuvegan Rao. My student ID will be DN 2012. So today I am representing Group 5 on the subject Technology Design Project, also known as TDP. Our project title will be Carbon Monoxide Automatic Detection System using Arduino. So without wasting any time, I would like to introduce to you my group mates. We'll start off with Muhammad Khairul Dimas, Muhammad Azizul Isman, myself, Yuwegan Rao, Muhammad Nur Fadlin, and also Nur Auni binti Razali. So as you can see on the screen, this will be our content for our presentation. We will go through this one by one. So as for the project descriptions, carbon monoxide auto detection system, automatic detection system is an electronic mechanism system that detects leaking gas of carbon monoxide. So this electronic tool uses the MQ9 sensor as the main component sensor to detect carbon monoxide more precisely. The project functions when the gas leaked inside the factory and the MQ9 sensor will start sensing the concentration of carbon monoxide gas. And if the sensor detects high concentration, the sensor will transmit the data to the indication part, which is the LED will turn from green to red, and the display indication will display warning gas leakage detected, as well as triggering the buzzer. So why we came up with this idea? So the problem statement is, it is impossible to identify the dangerous gas without the presence of a gas detector. So there are a few issues that we are going through that has limited capabilities of carbon monoxide detectors. IoT applications are not being used enough to monitor and detect system. Uh, Thirdly, the need to address the issues of carbon monoxide not being detected. And finally, the need for information and warning about carbon monoxide on its importance in our daily lives. On the other end, our concern to this project is to make sure no one gets themselves into danger and to be cautious at all times by getting alert on the alarm and readings of carbon monoxide. So our project aim is basically to provide information and warnings about carbon monoxide present in enclosed spaces for workers and employers, as well as for industrial hygienists. Also, other occupational safety and health professionals who may need such information. So there are three objectives in this project. Firstly, to design circuits for detecting carbon monoxide. Secondly, to develop the designed circuit that consists of MQ9 carbon monoxide sensor, buzzer, and also an LED. Thirdly, to evaluate performance of a carbon monoxide detector. So for this project, we also have several scopes which we would like to introduce, which are to measure the pH of the air as well as the amount of carbon monoxide gas that is leaked from natural gas utility pipes or from incomplete combustion of fuel, wood, or coal. A device requires testing using an Arduino Uno to get the pH value of the air and carbon monoxide leakage, which we have used in our project as well. The MQ9 sensor, gas sensor, is to read the concentration of carbon monoxide leaking. The LEDs are turned on and the 5-volt buzzer activates. We also have LCD to display the pH value of the air, as well as it also gives an alert which says a gas leakage detected. And finally, we have exhaust fans, which removes unwanted odors. So without further ado, I would like to present about the literature review as well. So this chapter discusses about the concepts of carbon monoxide automatic detection system to describe the existing design and review the extent to which this project can be implemented. Carbon monoxide detector was chosen to be developed in this project because it was relevant based on cost and size involved. Carbon monoxide, usually known as CO, is an odorless, colorless, and also colorless gas that can be hazardous to our health. Monitoring the content of carbon monoxide is one method for determining the level of pollution caused by the gas and for coming up with a solution to lessen the quantity of it is produced. So as you can see on the screen, these are the comparison between the previous related project. So as you can see in the table, the first one will be carbon dioxide and carbon monoxide detector. So the method used here is almost the same as our project, just that they used a different sensor as well, which is MQ135 air quality sensor and also MQ7. The reading of the sensors are displayed in particles per million ppm unit. It is a portable device, which is also same as ours. For my microcontroller, it uses Arduino Uno RT. It also uses LED display and buzzer as output device, just like ours. Our project. So the comments on this project is it uses multiple sensors because it needs to detect different types of gases. So our project is to detect carbon monoxide. The device in the project is portable and can be used anywhere. So the second project which we got introduced to is the design and implementation of carbon monoxide protection using Arduino with alarm. So it uses the MQ7 carbon monoxide gas sensor as the previous project. For microcontroller, it uses MCU ESP2866. It uses LED and active buzzer as output device. For displaying output reading, it uses a Blink application. So the difference with our project is it have real-time output and it can be monitored using mobile application. So these are the other examples of the previous related projects. So we just go through a quick one. So mobile carbon monoxide monitoring system based on Arduino MATLAB for environmental monitoring system. So this project uses MQ3 gas sensor and MQ7 carbon monoxide gas sensor. For output, the data from the sensor is transmitted by RF transmitter. So the difference is that the output from the sensor is more detailed with data recording in Excel and data monitoring in MATLAB. The fourth project will be low-cost carbon monoxide detector integrated with IoT. So this project also uses the MQ7 carbon monoxide gas sensor for microcontroller. It uses MCU ESP2866. It uses LED and active buzzer as output. For displaying output reading, it uses Blink app as well. So the difference with this project is the project uses a mobile application as output, which is the Blink. It is suitable for individual use because each individual needs to have the application installed on their Android or any smartphones. So the final previous related project will be design and implementation of IoT prototype for the detection of carbon monoxide. So this project uses the MQ2 gas sensor. For microcontroller, it uses VMOS D1. It uses LCD display and DC fan as output device. For the sensor to send alert messages, it uses push bullet and pushing box platforms on smartphones or desktops. So the difference with this project is it's suitable for individual use because each individual needs to have the application on their smartphones. This project also has real-time output. So without further ado, I will just brief about the discussion on literature review. So as you can see, as you all know, the other previous project has been mentioned in this chapter helps a lot in our systems development and improvement by system and hardware. So most previous projects used a high-end build sensor to be safer and better, but the quality of the sensor required more money. So the current project can be enhanced by the addition of a low-cost sensor capable of sensing CO gas. The size and housing of the project have played an important role in manufacturing the device. This is considerable measurement needs to fit the area. The carbon monoxide Arduino system, you only use a few important components and better quality housing with a smart microcontroller, the Arduino Uno, which makes the whole device cheaper and more affordable. So that's all from me. We'll move on to the next slide. Thank you.
Hi, my name is Muhammad Nofadlin, and I will explain about the methodology. So, for our project execution, we use a qualitative method. So, why we use this method? We use this method because it only involves the work of the group members in identifying the components and produce the project end product. So, this project uses automatic system with a microcontroller based electronic system. This methodology are divided into few subtopics that are discussed more in depth in the next slide. So firstly, we start with the system block diagram. As you can see, DC power supply will power Arduino Uno. From the input of Arduino Uno, there will be carbon monoxide gas. Carbon monoxide gas will be detected by MQ9 sensor, and the reading of the sensor will go into Arduino Uno and be interpreted. From the Arduino Uno, then it will go to a few outputs. First output is 5V single channel relay module with D10 switch, and it will output to buzzer, and the buzzer will emit sound. Second output is to resistor 220 ohm. The output from resistor is to power LED. Red LED to indicate warning state and green LED for safe state. Next output for Arduino is to the motor driver. Motor driver receive power from 12 volt input. Then it will output to exhaust fan. And lastly, output from Arduino Uno will go to I2C module. I2C module will power LCD display as a visible indication. And so we will see system flow chart. From the start of the operation, there will be push button on. Next, check carbon monoxide gas leakage. If there is no leakage, it will repeat the cycle and check the carbon monoxide gas leakage again. Next, if there is gas leakage, alarm will trigger and display on LCD warning message. Next, LED light will light up LED red LED, and exhaust fan will turn on, and it will be the end of the operation.
Assalamualaikum and hi. My name is Muhammad Khairudin Pramudia and my matrix number is DN210015. I will continue to the next slide, which is the 3D layout design for the carbon monoxide automatic detection system. The actual project device is actually based on the 3D layout design, which was built using the AutoCAD software. The 3D design is presented in 3 views, which is top view, side view and front view. This is the 3D layout design for the actual project, where the buzzer is placed on the side of the device with the electronic button. The MQ9 sensor is placed in front, which is opposite to the 2 LED and LCD display, while the DC fan will remain outside of the device and act as the suction fan. This is the circuit or wiring diagram in simulation in Proteus 8, where the MQ9 sensor will connect to pin A2 in Arduino, and the Arduino will be the main board. Green and red LED will be connected to pin 6 and 7 respectively, and will serve as a warning and a safe indicator. The buzzer will attach to a 5 volt channel relay module, and the power for the buzzer is 9 volt. The LCD display that we're using is 16x2 that will connect to an Arduino Uno board, Just as with the motor driver, which connect to from pin 9 and 10 on the Arduino, and in 3 and in 4 for the motor driver L298N. The DC fan 12 volt is connected to the motor drivers out 3 and out 4. For hardware and software list for the project carbon monoxide automatic detection system, the hardware that we're using is electronic button, potentiometer, motor driver, buzzer, 16x2 LCD display, relay, MQ9 gas sensor, LED, computer exhaust fan, Arduino Uno, and lastly is resistor. And for the software, we're using the Arduino IDE, Proteus 8, and AutoCAD 2020. This is the bill of material for our project, where include of 15 components. The total spend for this project is RM142.70, and the most expensive material in this bill of material is the Arduino Uno, which is RM59, and we do not mention hard plastic in the bill of material for the housing because the project housing uses a recycled hard plastic container.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurani binti Razali and I will present about result and discussion. For project hardware, from beginning the connection for the whole project, the gas sensor in the project need to be calibrated so that hardware tests can be performed on it. This particular plastic container is the most long-lasting option for the project due to the fact that the bulk of the box is composed of strong plastic molding. Initial state is around 17 to 22, so surrounding area is at normal level. Green LED will light up and LCD display will display no gas detected. DC fan not working because there is no presence of carbon monoxide gas. The trigger value is set to 100 for the system. Operation will begin when the sensor value equal to 100 or more than that. Red LED will light up and LCD display will display gas leakage detected. So the DC fan will operate to remove carbon monoxide from the surrounding by airflows. For discussion, these systems are basically designed to detect carbon monoxide gas leakage for installation area or factory. Then, this project also help to reduce carbon monoxide leakage inside the factory. This project also will certainly help to ensure working environment is safe. And lastly, the automatic operability of this system require minimal carbon monoxide gas.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azizul Isman. Okay, I will present about conclusion in our project. For result performance part, the gas detector MQ9 worked perfectly as it was able to detect the gas leakage by using combination of simulation and hardware implementation. The effectiveness of the system can be measured accurately. The separation system in the form of an fan is programmed to vent away the hazardous gas when there is a leakage carbon monoxide. This project also performed well in both scenario as well as reliable. Okay, next I will talk about achievement of all objective and scope. This project restricted to detect carbon monoxide leakage. This project also can accumulate in completely or partially enclosed space. Alarm will go off if the carbon monoxide level is too high. Next, this project also developed a low-cost device that can guarantee worker safety, simple and quick to implement. And lastly, this project can help by offering a straightforward project that can perform all of the functions same as pricey gadget which have the same function. Let's move to the impact of social environment and economic sustainability. For social, this project will do well based on the working environment. better time management, and invention opportunity. The lastly we get from social is the project could also be called a new portable sensing system because of its size and ability fit in industrial area. And let's move to for environmental. This project can reduce air pollution by alert someone or worker inside the industrial facility to the gas leakage. This device can ensure the surrounding air always clean if carbon monoxide leakage happen. This project can also keep the ozone layer from depleting. And lastly, I will talk about for economic sustainability. This project has a low maintenance cost because of the low equipment cost and simple system operation. And lastly, we get from the economic sustainability, this project can reduce potentially damage and have a low application. Lastly, I will talk about the project feature recommendation. Okay, the system should be upgraded to the wireless version in the future, such as IoT. It is because IoT platform is the current technology trend in the industrial revolution. Change the size the detector to a pocket size and make it device portable and which is fit in pocket size. We could carry anywhere and check the air condition whether it's clean or polluted. Okay, that's all for me. Thank you.